What we're going to do is we're going to look at a matrix and we're going to find a basis for the null space in the range of that matrix along with a basis for the null space in the range of the transpose of that matrix. After we do that, we're going to find a basis for the orthogonal complement of the null space of that matrix, and we're going to find a basis for the orthogonal complement of the range of that matrix. Okay, so what do we need to do first? Let's start off by finding a basis for the null space and a basis for the range. So remember that what we need to do is we need to first put this matrix in reduced row echelon form. So let me copy this matrix and put it down here. Okay. So let's put it in reduced row echelon form. So what I'm going to do is I'm going to subtract row 1 from row 3. So negative row 1 plus row 3. That's my first step. So this will be negative 1, negative 2, negative 1, negative 3. I get 0, negative 1, negative 2, negative 3. And then I'm going to divide this row by 2, so 1/2 of row 2. And then I'm going to get rid of this third row by adding row 2 to row 3. And I want to get it in reduced row echelon form. This is in row echelon form. So the last thing I need to do is get rid of this 2 here. So I'm going to multiply row 2 by negative 2 and add it to row 1. I guess I could have done that earlier, but that's okay. So this is negative 2, negative 4, negative 6. So I get 1, 0, negative 3, negative 3, 0, 1, 2, 3, 0, 0, 0, 0. So this is my matrix in reduced row echelon form. Now how do we figure out the null space? Well, remember that the null space of a matrix is the set of all vectors x in, well, this matrix is a 3×4 matrix. So it's all the vectors in R4 such that A times X is the 0 vector, which is a 3×1 matrix. So all we need to do now is we just need to make this an augmented matrix. Remember that this corresponds to the x1, this is x2, x3, x4. And we solve for the pivot, so we get x1 is 3x3 plus 3x4. And x2 is negative 2x3 minus 3x4. Okay? So knowing that, we have that the null space is the set of vectors 3x3. Let's put a letter in for x3. So let's let x3 be s and also x4 be t. That way we just don't have so much to write. So we have 3s plus 3t and negative 2s minus 3t. Then s and t, such that s and t are real numbers. So this is the null space. And we want to find a basis for this. So notice that 3s plus 3t negative 2s minus 3t st is the same thing as pulling out this s, 3, negative 2, 1, 0, and the t is t times 3, negative 3, 0, 1. So a basis for the null space is 3, negative 2, 1, 0, and 3, negative 3, 0, 1. So just these two vectors are the basis. And the span of the basis is the null space. Okay, I want to copy this. I'm going to need it later, so let's copy. And then I want to just erase all of this stuff. Actually, yeah, let's delete that. And I'm going to erase this too. Okay. And let's paste this. We can put it over here. Okay, so this is our null space. So we're gonna leave it over here so when we need it, we can use it again. And I'm gonna put the range underneath it. So let's figure out what the range of our space is. So looking back at our matrix, it's right here. Let's recall what the range of the matrix is. So the range is the set of all vectors y that belong to, now remember this is a 3x4 matrix, and we're going to end up when we multiply it by something that's 4x1, we're going to have a 3x1 matrix. So it's the set of all y in R3 such that a times x is equal to y for x in R4. So that's just the definition, but remember that the range of a matrix is the column space of the matrix A, which some people abbreviate it as C parentheses with A inside. So it's just the column space. And we learned in the last chapter how to find the column space. And the column space, how to find it is you just find the reduced row echelon form of this matrix, which we've already done. It's right here. And then we look at the pivots of the matrix in reduced row echelon form. Here's a pivot, here's a pivot, and this is in column 1 and column 2. So the column space, we look at the original matrix, and these two columns, column 1 and column 2, that correspond to the pivots, those are the columns that are a basis for the column space, which is also a basis for the range. So C1 is 1, 0, 1, and C2 is 2, 2, 1. So that tells me, I'm going to scroll over here so I can write down the range. The range of A is the span of those two vectors, 1, 0, 1 and 2, 2, 1. And these vectors are linearly independent and they form a basis for the range. So again, the two vectors themselves, those are the basis. And the range is the span of those basis vectors. Okay. So what have we done? Let me clean some stuff up so it looks a little nicer. Oops. Okay. So we found these two already. Now we want to find the range of the transpose and the null space of the transpose. which is going to be basically the same thing. We just take the transpose of the matrix and we get that in reduced row echelon form. So let's erase all of this where we got this in reduced row echelon form because we need to take the transpose of that matrix. Okay. So if this is the matrix, the transpose, remember we flip it along the diagonal, so it's going to be 1, 0, 1, 2, 2, 1, 1, 4, negative 1, 3, 6, 0. Okay, and this is a 4 by 3 matrix. I'm going to copy this and we're going to move it down here. Let's paste. Okay. So what do we need to do? We need to get this in reduced row echelon form. So I'm going to get rid of all of these numbers here. And of course you can, if you'd rather put this one at the top, or you can move these rows around. I'm going to get rid of, but that's what I'm going to do. I'm going to multiply this by 2, get rid of that, a negative 1 and a negative 3. So let's do that. 1, 0, 1. So if I multiply it by a negative 2, I get 0, 2, negative 1. If I multiply by negative 1, I'm going to get 0, 4, negative 2. Okay. Then multiply by negative 3. I get 0, 6, negative 3. What do you notice about these rows? Well, they're all multiples of the first row. So then I'm just going to eliminate these two rows and I get 1, 0, 1, 0, 2, negative 1, 0, 0, 0, 0, 0, 0. Okay, and let's also make this a 1 so we can get it in reduced row echelon form. Remember the pivots have to be a 1. Great. Okay, so we can figure out the null space and the range of this matrix easily. Actually, the range is the easiest thing because we look and see where the pivots are. Here's a pivot, here's a pivot. This is column 1, column 2. So we look at our original matrix, column 1, column 2, and that is the basis for the range, because the range is the null space. The range is the column space. So let's write that down. The range of the transpose is 1, 2, 1, 3. Zero, 2, 4, 6. Okay, now let's figure out what the null space is. Again, what we can do to figure out the null space is make this an augmented matrix. So we take that reduced row echelon form, we put a big line there, put 4 zeros. Remember that this is the x1, x2, x3 spots. So we get x1 is negative x3 and x2 is 1/2 x3. We solve for the pivots. If we let x3 be, you can say s, then we find that the range, the null space rather, the null space is the set of all vectors negative s, 1/2 s, s, such that s is a real number. Again, we can find a basis for this. So the basis is actually, it just has one vector. So it's the span of negative 1, 1/2, 1. Oof. about that. Okay, great. So let's erase some of this stuff and kind of put it close to the null space in the range over here. So I'm going to just get rid of all of this. Okay. And let's move this stuff up here. I don't need this. Okay, now we found part A, which was to find a basis for the null space in the range of A and the null space in the range of the transpose. And here are the bases. Let's kind of bring these a little closer so we can get them all together. Okay, so null space and range, and null space and range for the transpose. So part A is done.